solving right triangles. This is section 5.5 in your book. Okay. So, again, see the table on page 305, or you can use your unit circle printout if needed. So, my first one, it says it's an equation. Sine of x is equal to radical 3 over 2. Now, they're not giving me the angle. Do you see that? That's what I need to find, is the angle. So I need to identify which angle has a sine value of radical 3 over 2. So if I go to my table over here, there's going to be more than one answer, because radical 3 over 2 as a sine value appears here at 60 degrees. Also appears here at 120 degrees. Does it appear anywhere else? No, because down here these ones are all negative, right? So when they're asking this question, they're asking me what angles have a sine value of radical 3 over 2. Well, 60 degrees has a sine value of radical 3 over 2. 120 degrees has a sine value of radical 3 over 2. And any angles coterminal with those two angles. So not just 60 degrees and 120, but anything that is coterminal with 60 degrees has the same sine, cosine, and tangent as 60 degrees. Anything coterminal with 120 degrees has the same sine, cosine, and tangent as 120. Okay? So you see if you can answer number 2. Which angles have a cosine of negative root 2 over 2? What quadrants is cosine negative in? It's only positive in 1 and 4, so they'd be a second and third degree angle, or second and third quadrant angle. So cosine is negative radical 2 over 2. I see it at 135 degrees. Yes? And where else? 225 degrees. 25 degrees. And any angles coterminal with those.
Miss Franken?
Yes.
Why wouldn't you put 315 degrees? Is it because it's on the y?
Because this is asking for a cosine that's negative, and if you look at the chart, cosine in the fourth quadrant is positive. Cosine's the second row. If you see the negative one, you're looking at sine, not at cosine. Okay?
Oh, okay.
Yep.
Right, thank you.
Uh-huh. Okay. Any other questions about 1 and 2? We good? All right, 3 and 4, evaluate each expression. Assume that all angles are in quadrant 1. Now, you may see these more frequently with parentheses like this. Okay? And that little -1 right there means that we are talking about the inverse of tangent. So that right there means the inverse. It's an inverse function. I don't know if I want to say inverse of tangent because I don't want to get it confused with cotangent. But what it actually, you'll often hear it referred to as arctangent, which is represented by ARCTAN. Okay? So this problem could also be written tan arctan of 6/11. Could be written either way, and you'll see it both ways on your homework. Now, on your calculator, you're not going to see arctan, right? I see the tangent -1, but on some other calculators, especially if you have an older calculator or I think Desmos, it doesn't say the tangent -1, it says that right there. Just know that those functions are the same thing, okay? So inverse tangent is the same thing as arctangent. Inverse sine is the same thing as arcsine. Inverse cosine is the same as arc cosine. There's arcsecant, they all have those, okay? So what is this asking me? Well, this right here is saying, what is the angle that has a tangent value of 6/11? Well, I could go and I could draw a triangle, right? Opposite over adjacent, so that would be opposite over adjacent, right? That would be my tangent. Yes? Do we follow? So once I identify what that angle is, they're asking me to find the tangent of that angle. Well, isn't the tangent of that angle 6/11? So what's kind of nice is when you have a function and then the inverse function, it just kind of cancels out and your answer is just 6/11. So if I have sine arcsine, it's just going to equal that. If I have cosine arccosine, it's just going to equal that. Because it's asking me what's the tangent of the angle whose tangent is 6/11. I hope that kind of makes sense. Okay. Hopefully it'll make more sense as we go through, because these three ones are also very similar. So this one right here, cosine arcsine of 2/3. So let's think about this. Again, assume that the angle is in quadrant 1. So again, I'm just drawing a quadrant 1 angle. And I know that sine is opposite over hypotenuse, right? So make your triangle. Theta is always at the inside. Opposite is 2. Hypotenuse is 3. Yes? And they're wanting me to find the cosine of this same angle. So how am I going to find the cosine? Well, cosine is adjacent over hypotenuse. And I know the hypotenuse is 3. How am I going to find the adjacent? Quadratic formula. I'm sorry, Pythagorean theorem. A squared plus 2 squared equals 3 squared. A squared plus 4 equals 9. A squared equals 5. A equals rad 5. So if this side is radical 5, my answer is radical 5 over 3. This is very similar to those questions, the question on the quiz where I said something to the effect of find the tangent of the angle if the sine is blah, blah, blah. It's very similar to those questions. Okay. 5 and 6, let's move them around to a different quadrant. So this one right here is in quadrant 4. So I need to picture an angle in quadrant 4. Again, draw your triangle to the x-axis. Put your theta at the origin. Now they're telling me that arctangent, tangent I know is opposite over adjacent, is 4 is my opposite, 3 is my adjacent. And they want me to find cosecant, okay, of that same angle. So what is my hypotenuse going to be? 9 plus 16 equals c squared. And if you remember any of your Pythagorean triples way back from IM2, 3, 4, 5 is a triangle that you can get there. So cosecant is the reciprocal of sine, right? I know that sine is opposite over hypotenuse, therefore cosecant is going to be hypotenuse over opposite. So that would be 5 over, opposite is 4. And why does it specify that it's in quadrant 4? Well, something I didn't take into account here when I drew my triangle was what is negative here. Because yes, this is a positive x value, that's technically a negative y value, isn't it? So it should be a -4, because all students take calculus. Cosine and its reciprocal are the only ones positive here. So I should have a -5/4. So the fact that they're giving me a quadrant here tells me that my answer could be negative. If it says assume they're all in quadrant 1, well, everything's positive in quadrant 1. Okay? All right, you take a minute and you try number 6 on your own. Did you get 2 rad 2 for that other side? Because radical 8 simplifies to 2 rad 2. So the cosecant is the reciprocal of sine. It's going to be the same thing as I did over here. It's going to be hypotenuse over opposite. So the hypotenuse in this case is 3. The opposite is 2√2. Cosecant in this quadrant is at what? Positive or negative? All students, which means sine and its reciprocal, are going to be positive in this quadrant. So I'm going to multiply by √2 over √2. That gives me 3√2 over 2 and then 2. So I get 3√2 over 4, because that 2 has to be there, and then √2 times √2 gives me that other 2. So 3√2 over 4. Any questions about those guys? Those guys are all very similar. Okay. All right. 7, 8, and 9 are very similar to each other also. In triangle EDF, don't ask me why I didn't call it triangle DEF. It was a long day yesterday. So we have a right triangle. D is the right angle. And remember, capital letters are the angles, lowercase letters are the sides. So once I have my right angle labeled, it doesn't matter which one I call E and which one I call F. So what are they telling me? Little f is 17. Well, little f is directly across from capital F. So they're telling me this side is 17. And little d, that's going to be my hypotenuse. That's 32. And it says find capital E. That means this is the angle I'm trying to find. I'll call it theta. But angle E is what I'm trying to find. So what two things are they giving me with relation to angle E? 17, I would say, is the adjacent, right? And 32 is the hypotenuse. What trig function uses adjacent and hypotenuse? Cosine, right? So I'm going to say cosine of theta, well, we'll call it E. We'll stick with E since that's what I'm trying to find. Cosine of angle E is going to equal 17 over 32. Yes? Cosine E, sorry, my E's not very pretty, is 17 over 32. This is exactly like these first two problems. I need to find the angle that has this specific ratio. I need to find the angle that has 17 over 32 as its cosine. Now that's not a unit circle angle, is it? Because if I go look at that chart, none of those are even remotely close to 17 over 32. So I actually have to use my calculator for this. So what this is telling me is that if I use my arc cosine or my inverse cosine of 17 over 32, that my calculator is going to give me angle E. Now, again, make sure your calculator is in degree mode, must be in degree mode. And I'm going to press second cosine of 17 divided by 32. And the result that my calculator is going to give me is the measure of angle E. So angle E is 57.9 degrees. Does that kind of make sense? That's how we find missing angles. We use that inverse or that arc sine, arc cosine stuff. So? Yep.
It doesn't find the exact value though, like up on the direction. So.
Oh, sorry, that's the directions for these two. This
Okay.
was a separate set.
Cool.
Good catch though. Okay. All right. 8 and 9 are very similar. It says solve the triangle. What does it mean to solve the triangle? That means that at the end, you will know all three angles and all three sides. Okay? Triangle ABC we're talking about in both situations, and C is our 90-degree angle. Now, at the end of the day, I'm going to know angle A, angle B, angle C, and I'm also going to know little a, little b, and little c. That's what solving the triangle is. Now they're going to give me some to start off with. They're giving me capital A is 33 degrees, and little b is 5.8. Now from that, I should know that if I get a decimal, I'm going to round off to 1 decimal place, because that's what they're showing me in their example. If I draw my triangle, I'm going to recognize that I actually know one other piece of information, don't I? That should be a capital C. You guys are getting all my typos today. Capital C is 90 degrees. Label your other angles, A and B. So that's 33 degrees. Wouldn't it be pretty easy to find angle B now? Looking at that, because what do I know about the three angles of a triangle? They all equal 180, right? So 180 minus 90 is 90. Minus 33 means 57 degrees is angle B. That's my first step in solving. Okay. Now, let me label my sides. They're telling me little b is 5.8. Now, notice I did not fill in angle B into my drawing. I filled it into my answer column, but not in my drawing. The reason is because I don't want to use angle B to calculate either of my other two values. The reason is I'm pretty confident that 57 is correct, but if for some reason I got that wrong, I don't want to use it to find other angles or other measurements, because it's guaranteeing that those will be wrong also. So I always try to go back to what's originally given to me in order to solve them. Okay? So let's say that I want to find little a first. Little a is over here. Yes? So I have an angle, I have adjacent, and I have opposite. What trig function uses adjacent and opposite? Tangent. So I'm going to say the tangent of 33 degrees is equal to what? Opposite over adjacent. And this was kind of what was on the warm-up this morning. How do I solve that? Multiply by 5.8. Those will cancel. And 5.8 tangent 33 is 3.76. I'm going to call that 3.8 is my measurement for little a. So. Little c, I could use Pythagorean theorem if I wanted to, but again, try not to use measurements that you have gotten, because if I got that wrong, I don't want to use it to calculate something else. If I got it right, it's not a big deal, but if there's a chance I got it wrong, don't go there. So now I want to pretend like I don't have that. If I want to find little c, I have adjacent and I have hypotenuse. So what am I going to use this time? Cosine. So I'm going to say cosine of 33 degrees is equal to adjacent over hypotenuse. I'm going to solve it the same way. So I'm going to multiply by c. It's going to cancel there, but it's going to reappear over here. So I have c times cosine 33 equals 5.8. Divide by cosine. I have two s's there. Franken cannot spell today. Good thing it's Friday. Divide both sides by cosine 33, and I'll get my c value. So 5.8 divided by cosine 33 degrees, 6.91. We're going to call that 6.9. So c equals 6.9. And that is my solved triangle. All three angle measures are known, and all three sides are known. So. All right, last problemo. Solving the triangle again. So, angle A, angle B, angle C, and I just set this up because I like to be organized and know that I've answered every part of the question. That's why I do this. A, B, and C. And again, let me fill in what I know. I know that angle C is my 90-degree angle. They're telling me that little a is 23 and little c is 45. So if I draw my picture, C has to be here. A and B, it doesn't matter. But once I set A, little a is across from it. Little c is across from it. Now let's say that I wanted to find angle B first. Now this one's a little different. I can't just do the 180 minus like I could over there because I have two missing angles. So if I wanted to do, actually let's do A. Let's just go in order. So with regards to A, I have opposite and hypotenuse. So I'm going to say sine of A is equal to opposite over hypotenuse. How do I solve that? If I'm looking for the angle, I have to use my arc sine or inverse sine, because that's going to give me what A equals. So shift sine or second sine of 23 over 45. A is 30, we'll call it 30.7 degrees. Right there. Now, with angles, even though I say don't use what you got to calculate something else, I think with angles you're pretty safe. If you're concerned at all, use cosine of B is equal to adjacent over hypotenuse, and you can do your shift cosine. But just know that whatever you round off to has to make these three equal to 180. So if I do 180 minus 90 minus 30.7, this angle has to end up rounding off to 59.3 degrees. If you round it off to 59.2 degrees, you don't have 180 degrees there, and that's a problem. Okay? All right, last one, B. They gave me both of these, so I'm going to use these, and I'm just going to do Pythagorean theorem to find what side B is. So 23 squared plus B squared equals 45 squared. 23 squared is 529. And 45 squared is 2025. Subtract my 529. And I'm going to keep my fingers crossed that that's a nice square root. And it's not, of course. So 38.67, I'm going to call that 38.7. And on these solving ones, it's totally okay to go to decimal. Just round to the nearest tenth so you don't have a very long decimal. Okay? All right.